So now I'm going to start recording this lecture, so you can use the recorded video after session is ended. So in case you have a question, you can type a question on the chatting box on your left-hand side, but sometimes I cannot answer right away for smooth processing of this class. So today, we are going to discuss about how to model the database design, the logical modeling, conceptual modeling that we discussed on the last week. So this is the requirement of the company database that we are going to use this class. Also, we are going to use the example of the database throughout the semester for your better understanding. So it's a good idea to get familiar with this company database. I don't want to repeat the requirement of the company database, but you can find the information about the requirement of the company database from the Chapter 7 handout as well as the textbook. So this is the process of the conceptual design that we are going to discuss today. So last class we already talked about the first and the second step. That is the design of the entity type, the attribute of the entity type. Let me go back to the previous slide that is the illustrate that describe the requirement of the company database. Here we can see this is from your customer. Suppose that we are the database designer. So your customer asked to design their company database, so they explain about their database. So now using the provide information about the company database, you are going to design so high level, conceptual level database design, which means we are going to one step close to the database system. It's just the first step. So which means that we are going to organize such information. This is just the narrative description. So using the conceptual design, we are going to organize this information. So first step is we are going to find the entity type. So what is the entity type? Entity is existing things. For example, from the company database, we can, in this example, we already identified the several entities. So that is the department, project, employee, and dependent. However, this is not actually the entity. These are the entity type, as you can see from the first step. First step is the design of the entity type, which means that we are going to identify the entity type. What is the entity type? Entity type is an existing thing. It's a real existing. For example, so from your company database, we identify the several employees. So for example, so we have the Lee, and his ID is 111, and he lives in the 57 Tower View Drive. That is my address. And also he works for the IT department. And also we identified another employee, James, and his ID is 222, and his address is 100 University Avenue, and he works for the payroll office. And we identified the hotel, and the ID is 333, and he works for the main street, and he works for the HR department. For example, this is we identified 3 entities from the database. So each entity has something information. First one is the name, second is the ID, third is the address, the last one is the department name where the employee is working for. So we identify the 3 entities, then we realize that. So we realize that I'm sorry, I'm not very familiar with this one. I tried to my best. Okay, so we realize that first the information is the name, and second information is the ID, and third information is address, and the last information is the department. So actually this is the entity type. Entity type is the common information about a group of entities. So by collecting the information about the first information about the entity employee, that is the name. Okay. Then second is the ID. Third one is the address. Last one is the department. Then we can say the employee. The entity type is described by name, ID, address, and department. This is the entity types. So, in other words, entity type has a group of entities. Okay, then group of entities are described by a number of attributes. So that is the first and second step. So our goal is to find such an entity type. How can we find the entity type? Actually, we can define such an entity type by identifying a group of entities. However, it is true, just like this information, your customer does not provide the example of entity type. Instead, he just explained the employee. For example, here, how can I write the pen? Okay, just employee. Employee's social security number, address, salary, sex, and birth date. Already, your employee identifies such an entity type. So our goal is to identify such an entity type from the description requirement. So what else can we identify from what other entities type? So we can identify dependent, department, the entity type, and project entity type, and also dependent entity types. So also from each the entity type, we can find the attribute that describe the entity. For example, name, number, and employee who manage that department. And for example, for the project, we can identify unique name and unique number and location. Another example is employee we already did. The dependent, for the dependent, we keep track of their name, sex, birthday, and relationship to the employee. So these are the entity type and their attribute. That is the most important step of conceptual design. So after we identify the 4 entity type, it will be like this one. So after first and second step, we can identify the employee entity type that is described as birth date, department, social security number, sex, salary, and so on. So each attribute can be represented by the over and connected to the appropriate entity type. Similarly, we can identify the department, project, and dependent. At this time, we are going to use the ER diagram. It's a diagram. It's another notation of the ER modeling. Okay, because it's easy to understand the meaning of that design. So we are going to use such a ER diagram. So that is the reason the conceptual design is called the entity relationship diagram, ER diagram. Okay, so this time we are going to use the rectangle to represent the entity type, and we are going to use the oval to represent the attribute. From here, so you can find some unusual the attribute, that is for example work zone, like this one. The work zone has a double oval like this one, 1 and 2. So double oval means there are multiple attributes, which is called the multi-valued attribute. So in case it has a multi-valued attribute, you can use the double oval. Another example is the location. Location means one department may be located in multiple places. At that time, you can use the locations that represent the multiple location of the department. Okay. Another kind of attribute is this one. So you can see the F name and INIT is the middle name initial, last name LM is not directly connected to the entity type, but it is go through the name, which means it's a composite attribute. Composite attribute means the attribute is consisting of the several sub-components. For example, name consists of a first name, middle name initial, and last name. Another example is the work zone. Work zone consists of the project and hours. At that time, we can use the tree structure to represent the composite attribute. The last one you need to specify in this notation is the underline. So you can see the underline. Sometimes the project has a two underline, name and number, and department has the name and number, and also the employee has the social security number. Underline means it's the unique attribute. In case the unique attribute, you can specify the underline. So what does that mean, the unique? Unique means, in other words, using that information, you can identify the specific entity. For example, using social security number. Social security number is a unique number for each person, for each employee. So at that time, we can underline that attribute. What about the department? Department has the unique name and unique number. So which means using the name of the department, we can identify specific department. Similarly, using the number, we can identify the specific department. That is called the key attribute. That is key attribute. So underline means it's the key attribute. Okay. So, but sometimes you can find just one key attribute like the employee, social security number on employee. However, sometimes it can be multiple. Department has the two unique attribute, name and number. Project also has the name and number. It doesn't matter. Also, sometimes, like the dependent, you cannot find the unique attribute. So in conceptual design, it's not a big problem, no matter how many the key attribute or attribute you have. So because it's not a database yet, it's just a conceptual design. Okay, so this is the first step and the second step. Okay. So then So we complete the first step and the second step. The next one is the relation. Oh, before that, so we decide that this is the entity types, and these are the. This is the. This is entities, okay, and this is the entity type, okay. So using the entities, a group of entities, we can identify the entity type. That is our goal. However, from now on, we are going to use the entity type and entity. It's interchangeably. Which means if I'm saying the entity, that means it's entity type. If I'm saying the entity type, that means it's an entity. Okay, as long as you can identify, as long as you understand the difference between the entity and entity type, it's okay. So in the real project, when you are doing the conceptual design, conceptual modeling in your real project after graduation, so nobody use actually entity types. The most of the people use the entity that represent the entity type. So as long as you can understand what is the entity, what is the entity type, it's okay. But in your exam, maybe I can ask what is the difference between entity and entity type. But you can easily answer such a thing. So entity is kind of the real example, and entity types is the common information of the group of entities. That is our goal. The next step is the relationship type and the relationship. So what is the relationship? For example, the Prof, the Lee is working for the, let me add another example, the department. So department has, we have the HR, the 111-101, the HR, and location is the Bridgeport. Okay, then 02 payroll, and this is a Stanford. And finally, we can say, so this is the department number and the name and locations. So this is the department entity type, and so this is the department entity type, and this is the department entities. So we already identified this one. In this example, for example, Patel is working for HR department. Okay, when we identify such an information, Patel is working for the HR department, Lee is working for the IT department, James is working for the payroll, the department. That means we can find something relationship between employee, the entity type, and department entity type. It's a kind of the relationship between two entities. So that is the relationship. So relationship is the information between two or more entities. Let's take a look at the more example from the slide. Okay, so for example, we can find works-on relationship. Works-on relationship is the employee, not this one, not, oh yeah, here. So for example, John Smith works on the product X, the project. It's a works on specific project. The Franklin Wong manages the research department. We can find manage relationship. From here, we can identify the works on the relationship between the employee and the project. The manager is the between employee and department. This is the relationship. Then a group from the group of relationship, we can similar as we identify the entity type from the group of entities, we can identify the relationship type from the relationship. Okay, we can find more relationship from here. Like this one, this is the example. So works for relationship is between employee and department entities. Actually, these are the relationship type, not relationship. Relationship is kind of example. So for example, Lee works for IT department. That is a relationship. But we can find many such a relationship. Then we can say that this works for relationship type. So another example of the relationship type that we can identify from the example. So that is employee and department. So some of the employees manage the department. So other example is a control relationship type. So one department, the control the project. And works on is the between employee and the project. And supervising. Supervision is the employee supervising the employees. And also the employee, the dependent is the dependent of the employee. Okay, employee has a dependent. So this is the relationship type that we can identify at that time. So all of this, the relationship has the two entity type. At that time, we can say this is a binary relationship. Is it possible to have one relationship type has the 3 or more entity type? Yes. So we will see such an example later. So it's at least a binary, but it can be more. So to represent such a relationship type, we can use the diamond, like this one. Then connect to the corresponding relationship. So for example, works for is the relationship between employee and department, the entities. Okay. And another example is the manage, the employee manage the department. And similarly, we can do the works on, control, and dependent of. However, you can see that this is a little bit different from other supervision. Because supervision is who is the supervisor? Supervisor is also employee. So one employee is supervising many employees. So this is kind of the recursive, the relationship. So we can actually represent such a relationship as this one. This is also employee, and this is another employee. So supervision is the employee and employee relationship. However, physically it's one entity type, but logically it has the two, the relationship, the entity type. So it's still called the binary relationship. So we can find 1, 2, 3, 4, 5 relationship type from the company database example. At this time, can relationship type has the attribute? Yes. So for example, this one start date of the manager. Okay, or works on the hours. So if there exists, if you can identify, you can find such an attribute that describes the relationship, that can be attribute of the relationship type. Then we can use the over to represent it. So how many? So as many as possible. So if you can find more, so you can find it. But mostly, this is important, mostly, we will see. So first this one. So anyway, right now each relationship type can have the attribute. So then we can use the notation like the over and connect to this one. At this time, you can see such a something number and or 1 between the employee and department works for the relationship. This is called the cardinality. Okay. So the relationship cardinality. Okay. The relationship cardinality means how many entities are involved for the relationship. For example, one department has how many employees? Many employees. So many employees works for one department. That is the characteristic of the works for. That is the relationship cardinality. So at that time we can say this is the many to one relationship. Okay. So this is called the many to the one relationship, or this is called many to one relationship. Okay. So many to one relationship means many entities to one entity. Many employee works for one department. What about the manage? Manage, how many employee? How many the manager for each department? Only one. And how many the department can each manager manage? It's a one. So which means it's a 1 to 1 1-to-1 relationship. What about the works on? Many employees works on one project. That makes sense. One project has the many employees. And also, one employee may works on many projects, right? For example, the employee Lee works on project A, so half of the time. And also, employee Lee works on project B, so 50%. So, one employee works on many projects, which means many employees works on many projects. That is called many to many. So many to many relationship or end-to-end relationship. So there are three different types of the relationship. One is many to one. Another one is many to many. The last one is one to one. Why don't you think about the set theory that you learned before? So we have a set. So we learned the mapping, one-to-one mapping, one-to-many mapping, many-to-many mapping. It's exactly the same idea of such a mapping of in the set theory. Okay. Let's see the other example, supervision. How many supervisors for each supervisor? One, two, many. One supervisor has many supervisors. Like this one. One supervisor has many supervisors. So that is the reason it is one to many relationship. Dependent of one employee may have the many dependents. So it's a one to many relationship. Okay. That is the relationship cardinality. Also, you can find something different between works for and manage. If you see the works for, it is double line. And also this one is the double line. This one is the double line. But sometimes it's a single line. So relationship, the participation. The participation means whether this is a full or the optional, partial. The full means it's a mandatory. So at the time it's a double line. And otherwise it's a single line. So for example, employee, at least each employee should work for at least one department, right? Is there any employee who does not work for the department? No. It's a mandatory participation. So at that time we can use the double line. And department should have at least one employee. So to represent that, we can use double line. So this is the same thing. Each department should have at least one manager. At the time it's a double line. It's because it's a full participant. However, do you think the all employees are manager? No. Some of them are manager, the others are not, which means it's optional. In case optional, it's a single lane. So what about the works one? Each employee should work on at least one project, and each project should have at least one employee. It's a double lane. However, who decides whether this is the full or the partial, or mandatory or optional? It will be determined by customer requirement. So that is your job, whether this is a full or partial participation. Okay. So what about the supervision? Supervision is supposed to single line, which means it's optional. Why? Because think about the CEO, top of the employee tree. So CEO does not have a supervisor. So which means it's optional. Okay. So, and not all the employees are the supervisor, which means it's optional. So both sides are optional. So it's a single lane. So that is the relationship type. So then finally we can have such a thing. So here's a slide to explain such a relationship type. So many employee works for one department. It's a many to one relationship. Okay. Then this is the example of the many to many. See, the employee 1, employee 2 works on project 1, and also project 3. Each project has the many employees. So which means it's a many to many relationship. So if you remind the set theory that you learned in the middle school or sometimes the elementary school or primary school, it is easy to understand such a many to many, many to one, one to one mapping. Okay, so that is the relationship type and the design of entity type, attribute, and relationship type. The next one is we already talked about the constraint on the relationship, okay, and the attribute of the relationship type. The remainder is weak entities. Okay, the last one is a weak entity. So let's see the example of this one. If we see the I think this is not the good example. Yes, let's use this one. in this example, so why don't you take a look at the key attribute that we identify. So employee has a key attribute, social security number. It is underlined, right? And also department has a key attribute, two key attributes, name and number. So department can be identified by the name or number. What about the project? Project has the two key attributes, name and number. And also, yeah, that's the key attribute that we identify. What about the dependent? Dependent actually does not have the key attribute. It has the name, but name cannot be unique, right? Think about I have my son. I have one son. His name is Nicholas. Nicholas is one of the very popular name. So probably at UB there are employees who has dependent name Nicholas. So name cannot be the key attribute of the dependent. At that time, this is called the weak entities. So the weak entity means it's the entity that does not have key attribute, okay, like the dependent. However, later we are going to learn the main characteristic of the database object. Database, one of the main reason why we are using the database is to search the data. So at the time, if we do not, without the key, it's very hard to find such a data without key. So definitely we need the key of such an entity. In ER modeling, it's okay. However, so in database, so it's not defined. It's not okay without such a key. So how can we address that problem? At the time, we need to use the employee information to find the specific dependent. Okay. For example, we have the dependent name Nicholas. Who the dependent is the employee Lee. Social security number is 111. So using this information, Lee's dependent Nicholas, then we can identify the specific dependent. So at that time, this relationship is called identifying relationship. So identifying relationship. So identifying relationship can be represented by the double Identifying relationship can be identified, represented by the double, the diamond. So dependent of is the identifying relationship of the dependent weak entity. So at the time we can use the double, the diamond to represent the identifying relationship. Also similarly, we can use the double rectangle to represent the weak entity. Okay, so I'd like to summarize our step. Once again, we will use the clear one, chapter outline, conceptual design. Okay, so we discuss about the weak entity, and so these are the notation that we are going to use in ER modeling. The single rectangle is the entity, and double rectangle represents a weak entity, and diamond is a relationship. In case of the double diamond, is an identifying relationship. Identifying relationship is used to identify the key attribute of weak entity. An attribute key attribute is the underline, and multi-valued attribute, multiple value, like the location is the double, and composite attribute, this one, and this is the total participation, full participation, or the option, the mandatory participation. The single line is the optional or partial participant, and one-to-many and many-to-many. I do not explain about this one yet. Sometimes you can see dot, the over, like the dot. This means it's a derived attribute. Derived attribute is not actually the real attribute, but you can actually calculate, compute the value of that attribute. For example, GPA. So GPA is the average score of the grade, but actually GPA you can calculate. You don't have to put the information in the database. But it takes a time. Whenever the user access the GPA, if you need to calculate the GPA, so you can actually calculate, derive such a GPA information from existing attribute. At that time, you can use the dot line. So if we use this one, we can get the ER diagram. This is called the ER diagram. But so, for example, the employee is a rectangle, and weak entity dependent is a double rectangle, and also this is a multi-valued, and this is the identifying relationship. In case of the weak entity, we do not have the key attribute. We need to borrow the key attribute of this one to identifying the relationship, identifying the entity. And also for the relationship, we can use the diamond. Okay. Then also we can use single or double line. However, in this example, we do not use the single or double or the one-to-many. Instead, we use this notation. This is the different notation that I'm going to explain later. So why don't you keep your mind? This is another notation of the cardinality and participation. We will see later. Okay, this is the ER modeling. As you can see, this is basically finding entity and relationship. Then using the notation that we discussed here, so we can just represent. So compare. Why don't you compare this one with this requirement? Which one is easy to understand? Definitely, this ER diagram is much easier than your requirement. Also, as we discussed before, what is the data and what is the database? It's organized, meaningful information. It's a kind of organization. We organize such a requirement based on what? The concept of entity, concept of the relationship. So that is the ER modeling. Okay. So ER modeling is kind of the database. No, not yet. This ER modeling can be used for anyone, any application. Not only the database application, but also it can be used for our real life. So you can use even ER diagram to organize your daily life. So I have the school life, like the school, and I have the friend, and I have the something teacher information. Also, I'm taking the course, and you can find the relationship in your daily life. So this is the kind of the conceptual design tool. However, so this ER diagram, as you can see, quite similar as very close to the database concept. That is the main reason. So database community selected this ER diagram for conceptual design to kind of the first step of the database design. Even though this is not a database, it's easy to convert this ER model into the database. Okay? So that is the main reason. Another reason is ER modeling, as you can see, is very, very straightforward. It's very easy. So with a couple of practice, everybody can do such a modeling. When you are doing the ER modeling, the most important part is not the concept of entity, concept of relationship. No, it's just the basic and everybody can understand. The more important thing is the domain knowledge. Whether you understand such a company is there, or whether you understand library is there. So for example, if you are doing your project A for the ticket reservation system, first you should know how the reservation process is working. Without understanding such a domain knowledge, if you do not know how your ticket is reserved in the system, definitely you cannot design your database modeling. So this is the benefit of the ER modeling. So let's quickly go over the PPT file. Okay. So this is the company database that we have used. Okay. So ER modeling. By the way, the ER modeling is the only way to define the conceptual design of the database. No, you have used the different such a conceptual modeling before in your program language course, or sometimes a software engineering. One of the good example of such a conceptual level design is UML. So you use the object-oriented modeling, and you use the UML modeling, UML diagram. So there can be another example of the conceptual design. However, ER modeling is one of the most popular conceptual design method in database community. Why? I already explained the several reasons. Okay. So first, we identify the entities. Entity is actually such a real example, but by identifying many such a real example, we realize that employee is the kind of the type, entity type, that describes the employee, the group of entity information. Okay, that is the entity, and each entity has such a description like the attribute. There are three different types of attribute: simple, just a simple, so we can use this over and connect to the entity, and composite. Composite is like this one. It consists of the sub-component, like the address. Address has the string number and string name and zip code, something like that. And multi-valued is in case you have the multi-valued data, so we can use double over. This is important. Why we need to identify the multi-valued in ER diagram for database design. Later you will realize why. So right now I try to give the answer, but even though you do not understand why, it's okay. We will see later. Database, especially the relational database model that we are going to learn. Relational database model cannot handle such a multi-valued data. That is actually good or bad news. It can be good news, it can be bad news. The good news means because relational database has only single value, it's easy to find the data. However, the bad news is nowadays sometimes attribute has a lot of multi-value, like the color, location, and something characteristic, but it should be the relational database cannot handle such a multi-value. Because of that, actually relational database model will have a lot of small table later. You will realize later. Okay. Then types of the database. Also, we need to identify the key attribute for each attribute. Is it mandatory? No. Sometimes the attribute may have the multiple key attributes, or sometimes not. So it's okay in the conceptual design. However, later in relational database model, so that's not allowed, such a non-key the entity. So we will see later. Okay. Oh, one more thing is key attribute can be composite. Okay, so when you see this one, registration is a key attribute. Vehicle ID is a key attribute. There are two key attributes. So it's okay. However, sometimes it can be composite key attribute like this one. Registration plus vehicle ID can be key attribute. At that time, you need to connect on the line. Registration through vehicle ID. Okay, that is a composite key attribute. Composite key attribute also possible. In this example, car has the two car has the two key attributes, okay, and also registration is the composite. It's a composite, the key attribute. So if you want to represent composite key attribute, you can actually like this one without registration. Then connect it directly here. So it's also possible. And also it has the multi-valued the attribute that is colors. Okay, this is another example of entity. And entity set is nothing but entity type plus a group of entities. So that is called the entity type. Okay, so entity type is kind of a schema. It's a description, and entities are the instances. Okay, according to the database concept, it's the instances. So by combining this one, we said that this is a database state in terms of the database concept, but in ER modeling, this is called entity set. Our goal is to find such an entity set, and eventually we'll create the database. So relationship is the same thing. We can identify the relationship. It's kind of example. John Smith works on the product X. The Franklin Wang manage the research department. Then finally we can identify such a relationship type, works on, and manage, and so on. Okay. So these are our final example. Let me clear. Okay. So this is the final result of the ER diagram. Okay, before I move to the next topic, I'd like to take any questions. So please type your question, then I will answer. Okay, so if there is let me check whether there is any questions. Okay, so far no questions. So if you have any question, why don't you type on our chatting box, then I will. Okay. But I don't know how to There's one student who asked the question. Yes. What is the difference between identifying relationship and simple relationship? Okay, that's a good question. I understand. Sometimes the first time it's not easy. So this is a good example here. So let me use this one. So in normal, the general relationship has been identified using relationship type, like the employee. The Lee works for department, and the James works for HR department, something like that. Then we can identify works for relationship type. At that time, we can use a single attribute. However, if that relationship, like the dependent of, has an entity but without key attribute, that means it's a weak entity. So in case of a weak entity, we will use such a relationship as identifying relationship, which means using this relationship, we will see who is the employee of the dependent. For example, Lee has a dependent named Nick. So Lee is the employee of the dependent Nick. So then I can identify who is Nick, the dependent. At that time, this relationship is used for identifying weak entity. So that is the reason this is called identifying relationship. However, simply in case one of the entity is the weak entity, that relationship will be the identifying relationship. However, in real life, the example when you are involved in the real life project, so at the time, if you are doing the ER diagram, you may not see a lot of identifying relationship. Why? Because this time, how can you make the weak entity into the strong entity, general entity? You can use something social security number for the dependent. Then it's okay. It's not the weak entity. So that is a general actually. So, however, if you can see such a weak entity from the one of the entity in your relationship, that relationship will be identifying relationship. Okay? I hope this answer for your question. And I already explained a little bit about the recursive, the relationship. So recursive relationship actually is same as the general relationship. However, physically it has only one, the entity, such as employee to employee. So we have the employee, supervisor employee, and supervisee employee. Then we have the relationship between them, like the supervision relationship. Physically it's one, but logically it has the two. That is called the recursive relationship. It's a still binary relationship. Okay? So that is a recursive relationship. And weak entity type, I already explained. If that entity does not have the key attribute, or it has only partial key, this is called weak entity. Weak entity should be connected using identifying relationship. And next, the constraint that we already discussed about it. So when you're identifying the relationship, you need to identify the constraint. So cardinality. First, the cardinality. So one-to-one, one-to-many, many-to-many. You don't have to be serious about this. So just think about your knowledge on the set theory. So one-to-one mapping, one-to-many mapping, many-to-many mapping. Exactly same. The algorithm. Okay. Then you need to pay attention to many-to-many relationship. So during the Thursday exercise lab, you will see that this many-to-many relationship should be changed. So this is actually the key part of the ER diagram, that you identify the relationship. Many-to-many relationship later will be actually the table. This is important. But most of the relationships are not changed to the table in terms of database, but many-to-many is always the table. So we will see the more example when we are doing the exercise lab as well as the database, the relational database model later. This is a many-to-many. So mostly many-to-many relationship has such an attribute, like the employee works on specific project. You should know how many hours, or the percentage, like the 50% of the project A, 25% for the project B, and 25% for the project C. Then number of hours should be managed. However, sometimes the one-to-one, many-to-one may have such an attribute, but think about this is a one-to-one mapping. One-to-one mapping means start date, for example, in this case, can move to the attribute of the employee or attribute of the department. Also, if you have the attribute in works for, this one can move to the one side. So that is the reason attribute on one-to-one or one-to-many are not very important, but the attribute on the many-to-many are very important when you design the database later. Okay? So that is a cardinality that you can identify. Then, so we see the notation of this one. Okay, so we learned this notation. Is it general notation? No. So there are many different notation for the ER diagram. This is just one example used in our textbook and also mostly used. There are different notation like the crow foot. C-R-A-W, crow foot notation, like the, you know, the crow foot, like the foot of the crow. Okay, so you will see why it's called the crow foot. There is another notation of the crow foot, like this one represents one-to-many. Okay, so you don't have to stick on the notation of the ER diagram. So you can be flexible to use such a different types of the notation. So this is just one notation used in this textbook. Each textbook each author use a different notation. Even the tool that we are going to use, for example, Irwin. So we will use Irwin software on Thursday. Irwin used the different. They provide the different types of the notation, so which means different shape of the ER diagram. So you can change in the option or the preference. So you will see the crowfoot type, the notation later. And there's another example that is the many-to min-max notation. So in our example, yes. So in our example, we used in the previous, here example we used the many-to-one, one-to-one or double line. Double line means a full mandatory participation. Single line is the optional or partial participation. But sometimes we can specify more details of such a constraint, cardinality. For example, in this example, we don't know what is the minimum number of employees for each department. It's just to say it's at least one and many, right? But here we know the manager for each department, and one department has one manager. But here we don't know how many the employees are the maximum in specific projects. So to specify the details of the cardinality, we can use actually min-max notation. In terms of the min-max notation, we can specify minimum number of participation and maximum number of participation. For example, manager. Manager is in terms of employee, how many departments can each employee manage? Minimum 0 if you are not manager, and maximum 1 if you are manager. In terms of department, how many the employee for the manager? Minimum 1, maximum 1, because each department should have at least 1 manager and at most 1 manager. So we can use a 0, 1 instead of a double line. Okay, we can use the 1, 1 instead of many to many. So that is called min-max notation. Let's see the works for relationship. Works for we use just like this one, and full and many to 1. We don't know what is the minimum number of the employees for each department, but here we can see 1, 1 means minimum 1 department, maximum 1 department, which means each employee should work for 1 department. In terms of department, this is a 0, minimum 0, maximum n, which means sometimes there's no employee in this case, but maximum there's no limitation. That is the min-max notation. So this is another example of the min-max notation. Okay, so instead of the double line and 1, 1, we can use the min-max notation. Okay. So we can use minimum 0 department manage and maximum 1. Okay, if you are manager, it's 1, otherwise it's a 0. And similarly, in terms of department, each department has 1 manager from employee and maximum 1 the employee for the manager. So this is another notation. So we can use such a min-max notation. So using min-max notation like this one. Let's see in this example, you see the 4, n, which means each department has at least 4 employees. How can you decide what is the minimum, what is the maximum? Your customer will provide such information. Okay, sometimes from the given document, so you can find, as a designer, you can find such information. And here, for example, this one, 0, n means for each supervisor, how many supervising can use supervising? Minimum 0 if you are not supervisor, and there's no maximum, so it can be many. So that is the min-max notation. So in short, min-max notation can specify the details of the constraint or the cardinality of the relationship. Then you can easily understand the details of the regulation or such a constraint. Somebody likes the min-max notation, somebody doesn't like it, do not like it because it's too specific. So it's up to you. So in your project B, project A, page 2, you can use the min-max notation or you can use the general notation. So it doesn't matter. Also, if you want to use different notation, totally fine. Depending on your tool, so it can be Crowfoot notation or UML notation, it's totally fine. So you can use any notation. Also, once again, you can see the dot line, dot over, okay? That means that is the derived attribute. Actually, the number of employees you can calculate. You can count all the employees that belongs to the specific department. But if you wanna do this one in real time, it takes a long time. Whenever you are accessing such a data, you need to go to employee and count all the employees that belongs to a specific department. So you can make such a derived attribute. So when you build a database, you can count. But the problem is you need to keep updating such information. Okay. Then also there exists alternative diagram. Okay. For example, the UML diagram. So you can use the UML, the diagram, so that you learned in your programming class and object-oriented. I think that is called the 501, the class. Or the software engineering, you can use such a notation. It doesn't matter. It's just a conceptual design. So this is the alternative way to represent the same database, but using different the notation. Like this one use the UML class diagram. Okay. So some of you guys are familiar with such a UML diagram. Okay. And this is the other different notation using the conceptual model, ER model. But conceptual level, actually, meaning of this one, meaning of this one is exactly the same, but different notation. And before we move to the chapter, the 8. So one more thing. What if we have the several relationship, the several entity for one relationship? That is called an array relationship. For example, so this is an example. Supplier supply the specific part to the project. Okay. So supplier, the supplier A supply the part 1 to the project 1. So at this time, 3 entities are involved in the relationship. So this one can be actually understood as the 3, the binary relationship. This is the ternary relationship, but ternary relationship is not easy to intuitively understand. So in terms of the computer system, at the time we can use such a 3 binary, like this one, and this one, and this one. Or sometimes we can add supply entity and create the 3 binary like this. So it may be the same. However, actually it's not exactly same. Okay. However, this is an easier way to represent a ternary relationship. So many people use such a many binary relationship instead of the ternary relationship. The reason is that supplier only supply the part that are used for specific project. However, if you are using such a binary, there might be additional part that is not used for specific project, because it can supply any part, but that is not used for the project. Similarly, there might be the project, okay, which does not use a specific part, and also sometimes supplier does not supply all the parts that are used for project. So because of that, it's sometimes additional information are added, sometimes redundant information. Even though we have such additional information, this one is easier than the ternary relationship for understanding, so we prefer to use such a binary relationship. Okay, that is another example is another example of ternary relationship is the course. So for example, instructor offer the course for specific semester. However, if we represent such a ternary relationship with a binary, and binary, it's not same as the ternary, but it may have the additional information. Like for example, instructor Lee, Professor Lee can teach any course, but some of them are not offered in specific semester. Okay, so which means it has more the the information than ternary relationship. Okay, so that is the ternary relationship. In case of the ternary relationship, you can change it into such a binary relationship, but be careful. There might be additional information. So this is the ER modeling. So as you can see, ER modeling is quite straightforward, easy. So intuitively, most of the students can easily understand. Then, do we need to use such a the handwriting or the simple tool for such a modeling? No, there exists a lot of tools for the user to use such a ER modeling conveniently. That is the modeling tool. So for such a modeling tool, so we will use it. There are a lot of such a modeling tool, like as you can see here, the ER Studio, DBR Tension, or some of them are very expensive, like for example, rational rules. It's not only for the modeling tool, it can be used for such a component management. So you can use this tool. This is a very expensive tool, but among them we are going to use the Irwin software. I'm not sure whether that is here. Irwin software is one of the most popular and mostly used in the real-life project. So for your better understanding, better experience, on Thursday we are going to use the Irwin software for practice. But if your modeling is simple, like the classroom project in your page 2, project A, sometimes you can use the Visio, which is quite simple to use. It doesn't matter. Okay, so this is the ER diagram for the bank database. So this is your homework. So the GA will create the submission site on the page, the canvas. So why don't you try to understand? So for your practice, this is the given bank the ER diagram for the bank database. As you can see, it's a bank entity, bank branch. This is a double line. Double line means it's a double rectangle means it's a weak entity. Okay, so weak entity of what? It's a branch. Okay, so branch number, with a branch number you cannot identify the specific branch. You need to get the bank code and bank number, something like that. So first you need to understand the ER diagram and answer the given question. There are 6 questions, so why don't you submit your answer to the canvas by next week, Thursday, the Tuesday, 1 week. So GA, the Nemo, why don't you create the homework, the submission site, assignment site for this question. Okay. Then chapter 8. So we have, I'm going to spend 15 more minutes to explain about the extended one. Okay. If you are, I don't think you are in a hurry, so all the other classes are canceled. So let me borrow your 15 more minutes to explain about the extended part. So probably I cannot finish all the contents of the chapter 8, but the next week after exercise lab, I will explain a little bit more about this one. But the ER modeling is pretty much enough to represent the most of the conceptual level of the design of the information. However, it is not easy to represent some of the complicated concepts. So to address such a problem, so we are going to extend the concept of ER, entity relationship. So that is called extended. It's a E means the extended, or sometimes it's called enhanced ER diagram. So in addition to the general ER diagram, we are going to add some of the concept, that is this one, subclasses, superclass. Because you already learned about the object-oriented concept, it's not very difficult to understand subclass, what is a superclass, and subclass, like this one. So that is also, such a super and subclasses can be understood as a generalization and specialization. So generalization means if we have a car, so car is a superclass, and specific car like the truck and the sedan and some other the SUV. So these are the subclasses and superclass. And This is called specialization, and this is called generalization, right? And also we can categorize the car like this one. That is the union type. These are not possible in ER diagram. Okay, that is a problem of the limitation of the ER diagram. But as you can see, as we learned in other class, this is very popular in our daily life. So we are going to use extend ER diagram into the extended ER diagram to represent this kind of concept in chapter 8. Okay, so one of the example is the employee. Employee, we identify the employee as an entity. Actually, when you design the employee, even though your customer does not mention about such a detail, you may realize through the application analysis and the data analysis, you realize there are different types of employee, like the secretary, engineer, and technician. Also, you realize that the manager or non-manager or employee are salaried employee and hourly employee. At that time, this is called subclasses, and employee is called superclass. That is subclass and superclass, their relationship. So, in using ER diagram, it's not possible to represent such a super and subclasses. So we are going to extend. So that is this one. So this is the enhanced or extended ER diagram. First, this is we already done in ER diagram. This is the ER part. However, such a type of the employee, like the secretary, technician, and engineer, may not possible. And also manager may not possible. Hourly or salaried may not possible. So we are going to extend. At that time, how can we extend the ER diagram? Using subclasses. It's the same concept as the class concept that you learned in the object-oriented concept. So superclass is kind of parents, and this subclass is kind of a child. So at this time, don't be confused. Secretary, technician, and engineer are not separate entity. This is the sub-entity, subclass of the employee. So at that time, we can use such a circle to represent super and subclasses relationship. Okay. So what about this one? Hourly employee, salaried employee are not separate the entity. Instead, this is the subclasses, sub-entity of employee. So we can use the circle. Actually, manager, we have the circle here, but only one subclass. So in case one subclass, we are not using the circle, instead just a direct line. So let me clear the page. So at this time, here, how many entities can you find? How many entities? 1, 2, 3, 4, or more? The answer is there are 3 entities you can find. The first entity is employee, and second entity is project. Third entity is trade union. What about the others? Secretary. Is it entity? Actually, it's a sub-entity. It's a part of employee. Technician is also part of subclass of employee. Engineer is part of employee. So they are not entity. They are subclass of employee. They belong to employee. What about manager? Manager, it looks like the entity, but it's also subclass of employee. And what about the salaried employee? It's also subclass of employee, and hourly employee is also subclass of employee. So there are only 3 the entity types here. And one more. How many the relationship can you find here? Definitely this time we have 1, 2 relationship type. When you identify the relationship, when you make the relationship type, relationship also can be relationship with subclass only. It is possible. Okay. So then, let me clear. Then, how many super and subclass relationships are here in this the EER diagram? How many super and subclasses? It is 1, 2, 3. Answer is 3. So for example, this one is 1 super and subclasses. Okay, and another one is this one is a second super and subclasses, employee and manager. And third one is employee and salaried and hourly employed. So there are 1, 2, 3 super and subclasses. So that is mentioned here. Okay, this is an EER diagram. So we will see a little bit more about the EER diagram. Okay, so here you can see something letter of this one, the D. So when I said that we are going to use the circle to represent super and subclasses, in case of the one single subclass, we ignore, we omit such a circle. In case of multiple subclasses, we use the circle. Then, if the subclass, this subclass are not the overlap, which means the disjoint. Disjoint means each employee should be the secretary or technician or engineer. At the time, this is the disjoint super and subclass. So disjoint or overlap. So in case subclasses are not overlap, which means only one of the subclass, the superclass member of the superclass employee is one of the subclass, either secretary or technician or engineer. At the time is the disjoint. What is the opposite of the disjoint? Overlap. If you allow, for example, if you type O instead of the D over here, instead of D, if you type the O, which means the employee can be both secretary as well as the technician, or secretary as well as technician as well as engineer, or employee can be engineer, technician, overlap. So in case you allow such an overlap, this one can be O, overlap. So either disjoint or overlap. What about this example? This one. So hourly employee, salaried employee, this super and subclass should be either salary or hourly. You cannot be the employee both salaried and hourly. So that means it's a disjoint. Okay, so that is the disjoint or overlap. You need to decide. Another one is, you can see, I think that you can easily guess the difference. So that is, let me clear. So next one is, so this one. Sometimes you can see double line and sometimes a single line. Double line means we learned before. It is, yes, it's a full participation or mandatory participation, or it can be partial participation. Partial means optional. So which means in case of double line, all the employees should be either hourly or salary. There is no other employee who do not belong to either of them should be one of these. At that time, it's a double line, it's a full participation. What about the single lane here? This one is a single lane. Single lane means it's optional, it's a partial, which means there might be employees who are not belonging to any of these. So just the employee. Employee is not the secretary, not technician, not engineer, just employee. If you allow that, at the time it's a single lane. So there are 4 types of the super and subclasses. That is full participation and disjoint. Disjoint and full. Full, the overlap, or partial overlap, the partial, full and partial participation. So you need to decide such a full or the partial. Also you need to decide disjoint or overlap. That is the super and subclasses. And also there are important characteristics of the super and subclass enhanced one. That is, first one, this attribute. Sometimes superclass has the attribute. There exists the subclasses attribute. What does it mean? This attribute on the superclass will inherit automatically to the subclass. That's in general, that's the inheritance, the characteristic in object-oriented concept, right? Then, what about the attribute on the subclasses? These are not inherited. This is only for subclasses only. So like the pay scale is hourly employee only, not general. So that is the first characteristic of the super and subclasses. Another one, this is not very important in the database modeling, but when you decide that this kind of super and subclasses during the modeling, so you can actually identify that this one in 2 ways. First, for example, first you identify the employee first. Then you realize there are different categories of the job. Then you can first determine superclass, then subclasses. This is called specialization. This is called the specialization. Okay. At that time, you can use the symbol like the cup. It's not actually cup, from super to subclasses. On the other hand, first you realize the secretary, technician, and engineer. Then there might be common, all of them are employees. So you determine the employee superclass from subclasses. So that is called generalization process. Like that in this example, it's a generalization. So which means first you identify secretary, technician, engineer, and manager, salaried employee, hourly employee. Then finally, all of these are employed like this. But it's not very important in database design itself, because this super and sub generalization and super the specialization are kind of the thinking process, how you determine. So, but as long as you understand what is the generalization, what is the specialization, is totally fine. Okay, so that is the super and subclasses. So this is the example of the 1 super and 3 subclasses. Also, it's a good idea to specify type of such a subclasses. It's kind of job type, like this. What is this? It's an overlap or disjoint. It's a disjoint. Disjoint means it should be one of these. Doesn't allow the overlap. Okay, so it's either secretary, technician, and engineer. Also, it allows the partial participation, which means it's a single line. Single line means there might be employee who does not belong to any of these. Okay? That is the also subclass may have the attribute. So this is an example of the employee. So disjoint and completeness. Completeness is the disjoint means it's a disjoint or overlap. Completeness means full or partial. Partial, the constraint you need to determine. Okay. So there are 4 different disjoint, total, disjoint, partial, overlapping, total, overlapping, partial. So at this time, the disjoint or overlap can be represented by circle and D or the overlap, D or O. And total or partial can be represented by single line or double line. This is another example of the overlap, which means the part of the part can be both manufactured part and purchased part. So there exists a part. That part is actually manufactured and also it's purchased. So it's the overlap. But it's the double line. Double line means it should be at least one of these subclass. I'm going to explain about the later part, hierarchy, and the lattice, and the union type, the next class, probably next week, and after Thursday exercise lab. So why don't, before we conclude today's lecture, so why don't you take a look at this one. I have a question. How many entity can you find in this ER diagram? Anyone can answer? How many? Anyone? 2 or 1? Anyone? So actually it has only one entity. You can see there is a person entity, it's a superclass, and this is the super and subclasses. Also, subclass may have the subclass, and this subclass also has the subclass. So this, the research assistant is the subclass of the person, employee, student assistant, then this one. And similarly, the other is actually all of this, the person entity. It's only one entity. Okay, so this is the power of the ER diagram. Using ER diagram, definitely we cannot represent such a detailed meaning of that, but using the ER diagram, so we can represent such a details of it. So we will see a little bit more next week, okay, about the hierarchy levels and the union type. Then we can finally conclude. This is a full description of the university, the database, the diagram using the ER diagram. Okay. Let's see, is there any activity? Okay, so you have the homework. By the next week, the Tuesday, the GA will create assignment to submission site on Canvas. So you need to do the chapter 7, end of the chapter 7, 6 question, then you can submit it. If you write down with your handwriting, you can take the photo or scan, then submit to the Canvas. Also, on Thursday, if you are group 1, so in case of group 1, the exercise lab will start at 12:15 and end the 1:25. So please sit on. So we have exactly the 48 students, which means the 24 by 24. So please try to come to the lab assigned time. Okay. Otherwise, if you really wanna attend the others, I think that you need to bring your own laptop and so let the other student use the computer in the lab. Okay. And any questions? So you can leave. Thanks so much for your attending. So this one will be available as a recorded video. So if you have any question, I will stay the 5 more minutes. Okay, then we'll answer for you. Otherwise, you can ask a question in the classroom or the exercise lab. Thanks so much. Neema, are you there?